Then by the law of cosines, we know the square of this length is equal to the square of this length plus the square of this length minus 2 times these two lengths and times cosine theta. So you have the square of the magnitude of the a minus b equal to the square of the magnitude of a plus square of magnitude of b minus 2 times the magnitude of a times magnitude of b times cosine theta. And this is from the law of cosine. Okay. Now, let's plug in all the things into this equation. So you have the a1 minus a2 square plus b1 minus b2 square. This is the square of the magnitude of a minus b equal to the square of the magnitude of a, which is equal to a1 square plus b1 square. Then plus the square of the magnitude of b, a2 square plus b2 square. And then minus 2 times the square root. Okay, so here let me keep this magnitude of a and the magnitude of b. Now let's expand the left side. We have the a1 square minus 2a1 a2 plus a2 square and plus b1 square minus 2b1 b2 and plus b2 square equal to a1 square plus b1 square plus a2 square plus b2 square minus 2 times the magnitude of a times the magnitude of b and times cosine theta. So now this guy and this guy cancel, this guy cancel, and this cancel, b2 square and b2 square cancel. Then we just get negative 2 times a1 a2 minus negative minus 2 times b1 b2 equal to negative 2 times the magnitude of a times the magnitude of b times cosine theta. Now let's divide both sides by this negative 2 times the magnitude of a and the magnitude of b. Then we get cosine theta. And then we cancel this negative 2 from the numerator and denominator. And we get a1, a2 plus b1, b2 over the magnitude of a times the magnitude of b. Now, look at this guy. What is this? When you do the dot product with the A and B, you just get A1 times A2 plus the B1 times B2. So this numerator is exactly the dot product of A and B. So now we get the formula for the angle between the two vectors. So that is the cosine of this angle theta equal to the dot product of these two vectors divided by the product of their magnitudes. And since this is the angle between two vectors, so this theta is greater than or equal to 0, less than or equal to 180 degrees. Okay. So the two special cases is if the vector A and vector B have the same direction, then the theta is equal to 0 degrees. For example, you have the vector A like this and vector B like this, and then in this case theta is equal to 0 degree. Okay. And if you have the two vectors which have the opposite directions, then theta is equal to 180 degrees. And let's go to the next page. So if you have the vector A like this, and then vector B like this, they have the opposite direction, then theta in this case is equal to 180 degrees. Any question? So actually, you put these two vectors together, then you have the vectors B here, and then vector A here, right? So this guy is just the 180 degrees. And the process for deriving this formula is kind of complicated, but you just need to memorize this final result. Okay, the cosine of the angle between two vectors is the ratio of their dot product and the product of their magnitudes. And let's go to the page 612, and we look at the problem 54. So we need to determine whether this pair of the vectors is parallel, perpendicular, or neither. And before we can do this problem, let's talk about two more special cases for the angle between the two vectors.